Hello. So, we will be continuing our discussion on computer networks and internet protocol. So, we are discussing on layer 2 or data link layer phenomena. So, we have seen that aspects of flow control, error control in the layer 2 at layer 2 or the data link layer, which is one of the major aspect of things. Apart from that, the packets need to be switched, or what we say frame needs to be forwarded at the layer 2 level. As we understand that any upper layer packet finally becomes a payload to this data link layer, which needs to be forwarded to the next hop through this through the some layer 2 mechanisms, right. Or in other sense, whatever the logical address space is there, it need to be resolved to the next hop physical address to send the packet or the frame from one host to the next host next hop. So, it can be router to router, router to switch, switch to router, system to switch, and anything, right. So, that is why we will be today we will be looking at or maybe in coming 2 lectures we will be looking at different as protocols of the layer 2 phenomena. So, namely ARP, Rarp, Bootp-Dhcp, DHCP. Some of these protocols also we might have discussed in our earlier lectures or at the when we are discussing at the top level things. Nevertheless, what I felt that this has direct linkages with our layer 2 level switching or data link level switching. So, we thought that we should discuss with the perspective of the layer 2 or data link layer, right. So, if you look at the first protocol, which is predominant, is the address resolution protocol. Sometimes it is also known as a companion protocol for our IP network or IP layer, or what we say internet protocol in the layer 3. So, two machines on a given network can communicate only if they know each other physical address. So, this is bottom line. So, unless they know your physical address, they cannot communicate. Unless there is a physical connection, you cannot communicate, right. So, first of all the connectivity should be there, whether it is wired, wireless, whatever, but there should be a connectivity. If the connectivity is not there, whatever you do in the upper layer, you cannot communicate, right. Similarly, unless you know the physical address, you cannot push it to the next hop. So, ARP serves or address resolution protocol serves for mapping from high level IP address to this low level MAC address or physical address, sometimes known as loosely as network address also, right, or hardware address, so to say, right. So, that this ARP transform this from a logical address to this physical address. Now, what is this ARP? So, what we see first of all, every machine, every system, whether it is a PC or server or laptop or a router with multiple interfaces, we will come to that router etc. Otherwise, any devices or a printer which can be network enabled, any devices which are network enabled has a logical address or IP address and a corresponding physical address. And typically, we have seen that for IPv4, this is a 4 byte address space, and this is a 6 byte address space of the physical address. And also we learned that this physical address of a device is unique, that is given by the hardware manufacturer on the things. So, there again I am repeating, there are issues of cloning those physical address etc. We are not going to those complications, but physical address of a network device is a unique, right. Whereas, there can be multiple like logical address at the same time, but the router takes care of that how it to be there. Like these are private IP block. So, private IP block can be same for 10.4.10.90 can be in different places, right. But as private IPs are non-routable, so there is not a problem of clashing with other, right. Nevertheless, physical addresses are unique. Now, what I want to know, what we want to do, if I want to send a packet from here to here, so only knowing this logical addressing will not suffice, right. So, I need to know the physical address, pump that particular packet or frame in terms of layer 2 to this thing, right. So, if I only know the logical address, I need to resolve that. So, usually what happened? You when station A, this is B, want to send to A, station A knows his logical address or IP address and his physical address or MAC address, whereas for the where it wants to send, it knows its logical address or the IP address. B's IP address is known to this, but B's physical address is not known to it. So, for that it requires a resolution or resolving the thing, right. So, this IP, once I hit that give me this 10.4.1991 MAC address, it should respond to the things, right, or somebody else will tell me that this IP is this thing, right. So, that should be some address resolution protocol, right, that exactly ARP does. So, like ARP request from here to here or here to here, so different level of ARP request when the files are getting transferred, right. So, I need to know the physical address of the both the parties to transfer the packet or frame. So, ARP, so if there is ARP request, ARP responds with this. So, somebody requesting this first terminal, that what is your physical address. So, it will response will be like that, right. So, in other sense, as we have seen, what we have done, a logical address or the IP address to the physical address is the bottom line, or is the thing what ARP or address resolution protocol does, right. On the other hand, there is a concept of reverse ARP, RARP, right. So, that is from, if given a physical address, a logical addressing, I want to know the logical address, like why this is required, we will come to that, right. One of the thing what we can give, that if I have a some sort of a terminal, say dumb terminal or a systems where I have the physical address because I have an interface card, but somebody else need to give me the logical address. I do not know, I have connected this terminal or a systems into this network, and then I do not know that where the IP address is there. Either I ask the system administrator that give me the IP address and etc., and he gives the things, or I somewhere or other request to somewhere, like there may be a RARP server where I request to give me a logical address, that this is my physical address, give me a logical address of this network, and then I configure it, right. So, especially it is true for dumb terminals which are do not have their own configuration saved. They on the request on the during the boot or bootstrap, it requests for the IP address and then get connected to the things, right. So, in other sense I require some reverse resolution, right, and there are some other scenarios where I want to know that what is the logical addressing of the things. I might have get a request from the things, then I want to know that logical address of the of a particular system, right. So, those are different scenarios where this RARP becomes important. Now, as we are discussing in the TCP/IP protocol suite where this ARP or RARP sits, right. So, one of the one way of looking at it, they are interface between the IP and the your MAC layer or data link layer, right. So, why this? Because the one side they this ARP or RARP have that IP addresses, which is a logical address, which is a phenomena of a network layer. On the other side, it has the physical layer things. So, sometimes it is in several literature is referred to as a companion protocol to IP. So, helps in doing some sort of a address resolution at the data link layer. Okay. So, this is there. So, in other sense, in some of the literature you will find that it is a protocol which is in between, like IP and then down layer is the data link layer. So, this is the in between. Nevertheless, it resolved IP to physical and physical to IP and the reverse. So, ARP associates an IP with its physical address, or a typically physical network such as a LAN, each device on a link is identified by the physical or station address or network address that is usually imprinted on the NIC, right. As we are discussing that NIC is the network interface card which comes with the hardware address, and this ARP associates help us in associating IP address with the physical address or the MAC address, hardware address, network address, whatever we put, or NIC imprinted address or NIC address. So, logical address to physical address translation can be done statistically also. I can keep a lookup table that this is my logical address, this is my set of physical address, and do it. It is fine, so long it is not dynamic, right. The same systems are there and everything configured, then it is fine. Not only it is straightforward, it is also saves time on this address resolution. But in reality it is not like that, right. It is you are looking for a dynamic network and it becomes a huge headache that if there is a change you need to change everywhere and type of things. So, this ARP, this dynamicity are brought into the system. So, as we are talking that a system A and there is a wants to know about some node say system B. So, what it does, because system A does not know that which IP address, which one is the physical address, right. So, in a network the A wants to send to some system B, right. So, it is in the same network. So, it is single hop away, right, but the A does not know what is the physical address of the thing. So, it cannot send the DLL at the data link level or layer 2 frame to the B. So, what it first need to do, send a ARP request that say anybody is there with this IP, send me the physical address. So, ARP request is typically broadcast because it does not know that where the things will be there, right. Whereas, only one fellow will reply whose physical address, whose logical address matches with the IP and sends the physical address. So, it is ARP reply is unicast, right. So, it responses with the B's physical address, that is A460 whatever. So, whatever is there in the thing, right. So, this is a example we will find in some literature. So, this ARP is ARP packet structure or packet format is like this. So, one is hardware type, protocol type, hardware length, protocol length, operation type, that is one for request, two for reply, right. And then what we require, sender hardware address, sender protocol address, that is from the if A to B, A is hardware address, B is for sources hardware address and protocol address, and then targets hardware address and the protocol address, right. So, these are the things which are required out here. So, this is these are the things we require, but what happened that when you are sending a ARP request, it is not known, right. So, all zeros, right. So, it is not known that what is the targets hardware address, that exactly what the ARP request is looking for. So, hardware address for Ethernet type, it is typically the value is 1, protocol type for IPv4 which is predominant thing is 0x that is 0800, hardware length is the length of the Ethernet address, in this case 6, protocol length is the length of the IP address which is 4, right. So, these are the things which and operations is either request or response. For request we send 1 and for response 2. Now, how this ARP packet will be there? So, ARP encapsulation of the ARP packet. So, ARP packet is encapsulated within the Ethernet frame, right. So, it becomes a payload into the things. Rest you remember this preamble and SDF is 8 byte, destination address and so forth things are there. It is embedded into the thing, right. This is the Ethernet frame, right. So, type field of the Ethernet is 0x0806. So, 4 cases can be there, right, as we were discussing. One is that your host has a packet to send to another network on the same network, right, another host on the same network, it can be in the same network. So, target IP address, destination address in the IP datagram. Here the host want to send a packet to another host on the another network, that means the host will send to the router, right. So, it is on the other network, so it will send to the router. So, target IP address of a writer, in this case IP address of the in the IP destination address within the IP datagram, in this case the address is a router. Third may be the router receives a packet to be sent to a host on another network. So, it is a router to router. So, that need to be resolved, right. So, and finally, a router receives a packet sends to be the to the host. In other sense, one is direct, you can send to the host to host if it is in the same network, or host to some layer 3 device, and there from it goes on, and at the end of the things is happened, that is the to the host to router. Another can be router to router, intermediate communication, or router to host of the thing, right. So, this is the fourth thing. Now, incidentally, if you look at the router has multiple interfaces, right. Typically, a router has a 4 interface. So, 4 interface has 4 IP address, 4 IP address and interface at it says that it has a 4 NIC card, or in other sense 4 physical or hardware address. So, the router in a turn may have multiple or will have multiple this sort of interfaces. Now, it depends that where the connectivity is there, which path it is following for that one router to another. So, there it depends that which particular interface hardware address need to be resolved to get the get back the hardware address, so that the frame can be forwarded to the things. So, these 4 cases can handle all possible combinations. Now, one example again from some literature, if we look at a host with IP address 130.234320 and physical address something has a packet or layer 2 frame to send to another host with IP address so and so and physical address so and so, right. The physical address at the beginning, while that initial source system is sending to the destination, is not known, right. The 2 hosts are on the same Ethernet network. So, that means it does not require those router etc. Shows the ARP, we want to look at the ARP request and response. So, if we look at the ARP request path, so what it is happening, it does not know that what is the hardware address of the destination, rest are known, right, 130.23.43.20. So, these are things which are embedded into the things, right, it is known 130.23.43.20 in the hex, and it is also known that where 120.23.43.25 is the destination, that is this is also embedded, and this hardware address only it is what is not known is this one, right, the physical address of the things. So, make a ARP packet and forward it where it broadcasts, because it does not know who is the owner of that IP address. Now, on receiving, one of the fellows whose things matches is response with is the instead of this the physical address of the thing, right. So, for it its own address becomes the whatever the address, and the destination for it the destination becomes this hardware address and the IP etc. So, you see this one is mapped to this and rest are there, right, it has corresponding map. And then I do not require a broadcast at the layer 2 level, then I can do a unicast, because I know that where to be sent, right. So, it becomes again Ethernet packet and pushed into the network on a particular for a particular destination. So, that's why I can able to the things are. So, this is the ARP request and corresponding ARP response on the things. There is a concept called proxy ARP. So, this part is clear, right. So, just to before going to the proxy ARP, let me just repeat it. So, this was my protocol packet. What we get that once it is filled up, it is basically become a payload of the Ethernet thing, we are considering the Ethernet. Once that is there can be 4 cases. One is host to host, host to router, router to host and router to router. So, this can either in the same network or different network, and based on the things will be there. Then what we have trying to see that how these things are formed. So, I have that source having the IP and the hardware address. whereas the destination has the IP, but not the hardware address. So, the packet is filled up accordingly, right. So, this thing in the pink is that what is not known, and then once it is filled up, it is sent to the network in a broadcast mode, because the IP address is not known. Who is the owner of this IP address is not known of the destination. So, once that is pushed, this fellow reads this and responds back, resolve it, whoever is the owner of the things, resolve it in a unicast mode. So, this is a broadcast, whereas here we get as a B to A in a unicast mode. So, this is the bottom line of the ARP. So, this address is resolved. Now, a proxy ARP running in a router can, so there is a concept of proxy ARP. So, let us try to see what is a proxy ARP. So, at the term signifies it proxies for group of systems, right. So, as if it proxies for a group of systems. Now, a proxy ARP running in a router can respond to an ARP request for any of his proteges, that is for his backend systems. The proxy ARP replies with its own MAC address when the packet arrives, and the router delivers it to the appropriate host. So, what it happens that a proxy ARP typically running on a router, whenever there is a request come for a group of systems which is on the back of the router, it responded with its own IP address. That means, it proxies or take care of all the systems. So, it absorbs the packet and then push the packet to the rest of the network. The proxy ARP router replies to any ARP request received, right, for the destination so and so 141, 23, 56, 21. So, there are 3 systems 21, 22, 23. So, it proxies on the things. So, on receiving the things, it delivers the things and reply back and on their behalf. So, what it happens, we will see that there are lot of advantages in this, not only advantages, in some of the cases there is a requirement we need to do that. So, this is a special case of ARP, where one server is taking care of the things. So, proxy ARP or sometimes called also promiscuous ARP or ARP hack is a technique used to map a single IP network prefix to one or more physical address, right, using the same network address space for more than one physical address, right. Assume that there are two network A, B connected by a router R that runs a proxy ARP. So, using proxy ARP, R can use the same network ID for both the networks, right. So, this is the thing, it can do that proxy ARP. So, it is take this with a subnet mask. So, it with this particular router which is proxy ARP, another network may be a PPP network, network B, so and so forth. So, this takes care, connects those two network or proxying for both the network A and B, right. So, router R replies to ARP requests that are generated by the host on the PPP network, right, that is the network B, and in which the target IP is on the network A, namely it sends the MAC address of the thing, right. So, R knows which hosts are connected through PPP and so forth, right. So, these hosts assume that the destination host on the same physical network, right. In their ARP tables, the router MAC address is associated with the destination IP address, right. Advantage of the proxy ARP over the networking scheme is its simplicity of handling so many things. So, what is happening that in doing so, it as if thinks that it is in the same network. So, A thinks on the thing and then send the ARP request to that router, and which in turns replies back on this B, and on the other side it also takes care of the other part of the thing, that is the network A. So, it proxies on both the side. So, what it becomes, say I want to increase a system, decrease a system, so long I am handling within the network marks, I do not bother about updating the ARP table, etc. So, this is one major advantage of handling this type of things, right. So, and secondly, that the manageability is now concentrated within how to handle this router. Not only that, if we think little aloud that if we think little on the broader aspect, what we see that now I have a handler, or I have somewhere I can basically control this, who can access what, or if I want to keep something aloof, that this proxy ARP itself can be there. And in other sense, I can also restricting this broadcasting thing to a large thing, right. So, the broadcasting and congesting the network on a larger basis, I am able to restrict that. So, there are typical uses like joining a broadcast LAN with a serial network, dial-up, VPN, etc., where it will be very helpful. Otherwise, this interoperability, etc., has to be handled, that how these IP addresses will be addressed and so on and so forth. Taking multiple addresses from a LAN and making means more than one addresses from a LAN and handling them. On a firewall, I can have some sort of a firewall level what we say operations into the things. There are issues of mobile IPs, right, those IP which are mobile IPs, where also it will be very helpful. So, that I can have handling this mobile IP will be much easier. So, if we look at the ARP module per se, right, what that ARP want to will have. One is that I sends requests and other things, but from the operational point of view, then that may not be very catchy or helpful, right. One, so what are the things it may be there? There can be a cache table with caching that what is the recent resolution, so that if there is request coming within a shorter time period, it can reply from that cache only. There can be ARP queue, output module, input module, and cache control module. So, these are the typical modules which is there in a ARP suite, right, or what I can say ARP software package. So, cache table, if the ARP is just resolve an IP address, chances that are few moments later there is a request to resolve the same IP address. When ARP returns the MAC address, is placed on the cache. When the next request come for the same IP address, look at its cache and reply back. So, it saves time, saves network bandwidth, and so on and so forth. So, cache table typically contain a queue number, which queue the ARP request is sitting in, attempts, how many times it has been tried for the resolution, timeout, how long you can go on trying before the things that it is flashed out, hardware address, destination hardware address, and protocol address, the IP address. So, IP address versus hardware address is the mapping function, and there are other things which needed to manage those things. So, working of the cache is straightforward. That output module waits for an IP packet for a request, checks that cache for an existing request. If the entry is resolved, that is, or sometimes say that is the entry becomes R, we have already have this MAC address. If the entry found and the state is pending, packet waits until the destination hardware address is found. So, either it can be resolved or it is in a pending state. So, like typically original cache table use for those examples, if you look at, or some example scenarios, like we say that there is a state is resolved, queue is 5, timeout time is 900, after which it will be flashed out, protocol IP is this, and the hardware address is there. So, within that, if there is request come, so if it is a pending, so is there, it is still pending, resolve some of the things, and this timeout period is going on. So, after the timeout period goes off, the cache is flashed out. So, that it is a older version of the things. So, ARP output module receives an IP address from a IP layer with the destination address and so on and so forth, right. So, it is getting a module that 114.5.7.89, it is there 114.5.7.89, it is already resolved and resolved state and already in the timeout period, and finds that existing there in the resolved state ARP table, it extracts the hardware address, whatever the hardware address, and sends to the packet and the address to the data link layer for transmission. This cache table remains the same. So, it is nothing to change, it goes on doing that. So, scenario 3, the 20 seconds later ARP modules received a IP datagram for the destination 116.1.7.22. It is there, 116. It is not there, right. It checks the table and finds that the destination address is not present in the table, right. So, it creates a so the module adds a new entry for the state pending with the state pending and attempt is 1. It creates a new queue in the destination and enqueues the packet, is then sends a ARP request to the data link layer for the destination. The new cache table will be looking like this. So, there is a new entry of 116.1.7.22, right, 116.1.70 this with a P entry, and there is a new queue is there with the attempt is 1, right. Example 4, 15 seconds later the ARP input module receives a ARP packet with target IP 118.11.8.71, right. Again let us check whether it is there 118.11.8.71, it is there. The module checks the table, if the it changes the state to resolved, right. ARP module receives a packet with a target IP this, the module resolved and sets the second and 900, the module adds the IP address, a MAC address or the hardware address this to the entry. Now, it accesses queue 18 and sends the packet to the queue, the new entry is there. So, what is there? It was in a pending state, now it receives the thing what that is 118.11.8.71, 118.11.71 and then it resolves with the IP address, a MAC address like this. And there may be some 25 seconds later the cache control module updates every entry, the timeout values for the 3 resolved entries are decremented by 60 and the timeout for the last resolved decremented by 25. The state of the entry is resolved to free because the timeout is 0, right. So, for each of the 3 pending, it is what we are doing, it is some sort of a housekeeping thing. So, once it is there, it checks the timeout, decrements the timeout, or if it is the timeout has expired, it flush out the things and make it free, and then the new table becomes like, right. So, it goes on doing this so that. So, you see this table handles this IP with the MAC address, right, and also it go on updating it over on a periodic basis. Now, any request come first is to consult the table, right. So, this is important, this ARP cache table or ARP table is important because it makes a proper maintenance of the things, makes the overall communication process at the data link layer efficient. In other sense, at the all the other upper layer things much efficient to handle this, right. So, what we have seen now that how a higher level address or a packet coming from the higher level, this address need to be resolved to the hardware address, so that it can be transferred to the things, right, to the next hop. So, I again repeat, we all know that in order to transfer I need to require at the that level, that is layer to level hardware resolutions. Once it is done, the packet is forwarded or switched from to the next hop. So, with this let us conclude our this present lecture, and we will continue with this discussion in the subsequent lectures. Thank you.